So we're ready for the next presentation. Building an extension card for the TRS-80 Lessons Learned from the RetroStoreCard. In this presentation, Arno and Sascha will document the journey from understanding the TRS-80 I/O bus to a breadboard-based device, prototype to designing the PCB, as well as developing the accompanying software. They hope to inspire others to design and build their own extension card. So here is Arno and Sascha.
Well, hello everyone. So we flew in from San Francisco yesterday and we had some technical snafus. So while I was doing the slides, Sascha, my co-conspirator, was still fixing bugs. And since he hasn't seen the slides, I thought I'd be nice and just talk about them and not subject him to my concoctions here. So anyways, thanks for coming. And I guess it's customary to tell your personal tale about how you started with the TRS-80. I guess you can tell already that I'm not from around here. So as a matter of fact, I grew up in Germany. And it's interesting to listen to Arno's talk because there are some similarities and some differences. So I grew up in the rural parts of Germany and there was no community. There were no TRS-80 shops. So stories that I often hear among you guys here growing up in America, that you spent all your free time at a TRS-80 store and a Radio Shack store and then hacked away like what Arthur was talking about. I didn't have that. For me, that was my neighbor. He had one time a Model 3 that he bought for himself. And according to my parents, I was not seen anymore at my parents' house. So the only way for my parents to get me back to their house was to buy me a clone. So actually, I was very fortunate. My parents got me a Dick Smith, I think they were called here in America. In Europe, they were called Video Genie, but they were compatible enough that I could do everything that you could do on a TRS-80. And again, it was very interesting to listen to Arthur's talk. So I remember writing basic code and doing the same thing, copying pages of basic code, and then of course you made a mistake, you had to debug, and that's how I learned how to write code. And then this aforementioned neighbor then one time gave me a cassette tape with the Big 5 game. And up to that point, I had not seen machine language in action. I didn't really understand the notion of that there's something more than basic. And I was just blown away with the performance. And I said, how do they do that? You know, well, then of course I had to learn then Z80 assembly. And the only book that I remember ever buying was the Rodney Zach's pretty thick book on the Z80 CPU. And I also wrote my own little game back in Germany. I have a screenshot here. You can tell that I was heavily inspired by Big 5. So I also had this little ticker tape thingy going on and the little lights going around. So I literally was very much inspired by Big 5. But just like as a testament to time, you know, because it was about the same time that Arthur wrote his game back in the early 80s. If you look in the bottom right corner, you know, we have zip codes in Germany, of course, but I grew up in West Germany, so that was before the Berlin Wall came down. And we used to have 4-digit zip codes in Germany. And now after reunification, they unified it, now we have 5-digit zip codes. But you can still see on the bottom right, my home address, my parents, where they still live today, with a 4-digit zip code. So it's kind of like a testament of time. And if you let it run a little further, it just even says like West Germany. You know? So this is also like gone in time. But anyway, so then fast forward, so of course then I stayed true to the profession. I studied computer science. In the late 90s I came to America. Didn't really intend to stay in America, but then here I am 21 years later. I'm now working at San Francisco State, and it was maybe 10 years ago. I was rummaging at my parents' garage and I came across my old machine that no longer worked. So it was not properly stored. I plugged it in, nothing went up in smokes, fortunately, but it also didn't work. But then I found the old floppy disk of my game and said, well, is there no way how I can try to still run it? And then and I Googled a little bit, and I found it was emulators. So I downloaded XTRS, and I had now these 500-quarter-inch floppy disks, and my first task was to then scrape the data and just put it onto a modern machine. Well, I guess it's a testament to public schools, public universities in America, because even though 10 years ago we had an old 500-quarter floppy drive back at my university, so I was able to salvage the data, and then I managed to make it run on my PC back then. And when I saw this, like, I had totally forgotten those 4-digit zip codes. And when I first saw it like run by it, I almost cried. There was also the time that mobile platforms became popular. The first iOS device was sold in 2007. Android followed 1 year later, 2008. And I did some research on Android and iOS. So, and also became interested, wouldn't it be cool to then have an emulator for the TRS-80 for Android, which didn't exist at that time. And that was my next pet project, and I began that maybe in 2010, I think, working on it. And last year, we were here at Tandy Assembly, just gave a presentation only about the emulator and the RetroStore. But basically, it's we have taken, you always say you stand on the shoulder of giants. So we've taken XTRS from Tin Man, and Java lets you embed native C code. So basically, all we've done is just add a Java layer over it, just the skin, just the rendering, and also the keyboard, soft keyboard, and so forth. And then I think in 2013, April 16th, was the first time we went live in the Google Play Store. And what I'm going to try and do now is give you a live demo. I tell my students never to do live demos because it's bound to something go wrong. But let me try it nonetheless. Okay, I need to switch the screen here. Okay, so far so good. So here in the middle you see my Nexus 7 screen. Now, one thing that I also quickly found out, I mean, the way to use this emulator is that you have to copy disk images onto the SD card of this Android device, and then you have to mount them in the emulator and so forth. That is something that's not like super complicated, but we quickly found out that it was just a bit of a hassle to do that. And then some time ago, then Sascha and I had the idea of creating a RetroStore. So the idea being that we wanted to create the same experience that you all know from your mobile phone in terms of browsing app stores and then just with one click download and install an app. The same idea we wanted to do here for the emulator. That's what we're going to show you here. So I'm running on my Android tablets the emulator, and you can see there's on the bottom right there's a little shopping cart icon. Maybe it's a little bit too small, but let me click on that. And what happens now is it shows the listing of the RetroStore. That is the backend that Sascha has implemented. And you can see like all the games that we currently, and the apps that we have in this RetroStore. So I contacted also Bill Hope a couple of years ago. We were working on that, and he gave us permission for all the Big 5 games. And I'm happy to announce that Weird will also soon be available on the RetroStore. But basically, you can just look around here. Let me just, for the fun of it, take the game that Pete Zatinsky wrote, Breakdown. So there's a little blurb here. The text is too small to read, but it's the same experience that you know from an app store. And on the bottom, you can say install. And then you can, yes, I want to install it. It now downloads from the cloud service onto the SD card. And when I go back here, I now see I have a new card for Breakdown. And when I click on it, it runs now the emulator, it auto boots, and then you can see the soft keyboard on the bottom has the same layout as the TRS-80. And then you can play this game now on the emulator. Okay, so that is the game, by the way. Yes, please. Awesome game. And so we were here last year, Tandy Assembly, and that's basically what we presented last year. So the RetroStore and the Android emulator. We had a whole technical presentation on the inner workings of the RetroStore and also how we did the emulator. So I know that the recordings are floating around somewhere, so you can check the website from last year if you're interested in that. Now, since we were here at Tandy Assembly last year, we quickly also noticed that most people here are interested in real hardware. And up to that point, I only had worked in emulation. And, oops, I should not do that. So then I came back from Tandy Assembly last year, and I thought, well, wouldn't it be cool to then try to build an expansion card that allows you basically a user interface for the RetroStore that runs on the old hardware. So you have a client that lets you browse the content of the RetroStore and then download on the machine. And let me go back to my slides. So maybe just a few words here. So I have one slide on the RetroStore. So that, again, that is something that Sascha implemented. And if you want to know details, you can look at last year's presentation. Maybe just before I continue, just on the bottom here, one big difference is it's all like for free. I mean, there's nothing commercial here. And not only that, but the complete implementation, the source code of everything, the emulator and the backend implementation is on GitHub on an open source license. So anyway, so I come back from Tandy Assembly last year, and I think, okay, now I want to go ahead and build now an extension card to work on, to connect to a real machine. First problem, I didn't have a real machine. So I go to Craigslist, and luckily Bay Area, there are always people trying to get rid of clearing out some stuff from their basement, and didn't take too long. I had my own TRS-80, so that was great. So that's my machine. I'm very proud of it. So I had some issues getting it to work in the beginning, and Pete and Maverick helped me with some details on getting it up and running again, but then here is it in the working state. Now, if you take a closer look at the floppy drive bays on the right, they are just fake. So actually, whenever I turned on the machine, it was, of course, empty. There was nothing in there. I could type in some basic, but that was it. Now, I had the ambition, I didn't want to buy a hard disk or floppy disk. I had the ambition, or I didn't even want to get a fret card, this little extension card to emulate a floppy disk. I had the ambition, okay, the first time I want to see something running on my TRS-80s by my own hardware. So then I set out and began then designing and building this card. And what I'm going to do now is I'm going to first explain to you what I came up with, and then at the end of the presentation I have some details on then how I did it. Well, first of all, the idea is that we have an extension card here that plugs into the 50-pin expansion port of the TRS-80. And that is what you see on the, let me just turn off. That is what you see on the left side. You have the machine, the TRS-80, and then you connect to it this thing that looks a bit like Fred, except it looks, well, it's not exactly the same. And in the bottom you have this 50-pin ribbon band connector here, and that connects to the TRS-80. Now, one difference is to Fred is that we use a microcontroller that has a built-in Wi-Fi module. So this little guy here can go actually online connect to a Wi-Fi network. And then the idea is you have a native client running on the TRS-80. There's a little protocol that I will explain later that you talk to the software running on the microcontroller, and then with the help of the built-in Wi-Fi module, we then go off to the RetroStore and then do all the browsing and downloading. So here's a close-up on the RetroStore card. So just to show a few things, on the bottom again is the 50-pin connector. Then the top right is the microcontroller. I'll say a few things about that one later. We use the power supply, the micro USB connector to power this thing up. On the top left, there's a push button that you can use to reset it if you want to connect it to a different Wi-Fi network. There's a multicolor LED next to number 2 that gives you some indication on the state of the Wi-Fi. Yeah, that's pretty much it. You know, some DTL logic that also we'll talk about a bit later. Very simple design, and I was heavily inspired by Fred. So the guy who did the initial design of Fred Verkoven, I think is his name. So pretty sharp guy, and he also put down the initial design of Fred on the internet. So I took a long, hard look at that, and he was also kind enough to explain a few things. And I basically just mimicked it a little bit, but adapted it to what I wanted to do. So that's the hardware side, and then the thing is, okay, then how do you do then a store browser then on the real hardware? And so here's a screenshot that shows you a little bit then what the interface looks like. And actually, I can do again a live demo since I'm getting bold now. It worked fine for the first. Let me switch back the monitor here. So I'm launching now SDL TRS, which is another freely available TRS emulator. And basically here's then the user interface that you would see on the machine. By the way, we do have an exhibit here, so you can also take a look at that on the real machine. But what you see now is basically the window is this SDL TRS running now this native client for our RetroStore browser. And you can see that I implemented like a little menu system here, so you have like with the up and down key you can choose what you want to do, like about, gives you some details. So on the real machine it also shows you the SSID and IP address that the RetroStoreCard is connected to, and the various versions of the hardware software. And then you can go to browse RetroStore, and now it says loading, and that is now where the RetroStoreCard would do an HTTP request to download all the store listings. And here again you have a different menu where you can then just browse through all the various apps that we have currently in the RetroStore. And since I used Peter's fantastic game here, let me also do it here in the emulator. Breakdown, so you hit enter, and then it shows the metadata, so author, the year, and then some description. And if you hit enter again, then it will actually then download the CMD file, inject it into the RAM, and then jump to it and launch it. So that's basically then what you will also see on the real machine. So that is basically what we have, but let me then tell you a little bit about the journey on getting there. And you know, while I was pretty familiar with the details back in the days with the TRS-80, but I've forgotten a lot. And Peter was kind enough to send me a copy of the perfectly legal, I'm sure, scanned copy PDF of the TRS-80 Model 3 service manual. And that is basically the go-to thing if you want to understand these old machines. And you know, maybe just to mention one thing before I go into some technical details here, I just want to also highlight the passage of time here and the way many of you learn computer science, namely by just taking this machine apart and really understanding it end to end. And these machines were so simple back then, and you still can do that. You know, if I look at my nephews growing up with iPads, devices that are glued together, that are not meant for tinkering anymore. You know. So youth nowadays have a very different access to these technologies, but unfortunately, this kind of playful interaction with technology and then learning by doing something that many of you, and certainly I had, it seems to be like forgotten a little bit. There are some hopes like Arduino. I'm a big fan of Arduino, at least for education purposes and to bring young folks to technology. But again, like, you know, these machines back then were like the Arduinos of our times. So anyway, so the first thing when you read this document is then you come to a schematics that looks like this here. So that is a schematic for the TRS-80 expansion port, and there's a lot of horizontal lines here. You cannot make out all the details, and it's not so that important. Maybe just to point out a few things here. So on the left is basically the inside of the TRS-80. On the right, you see the actual 50 connectors, the 50 pins that you have then on the expansion port. And if you just look, maybe it's too small to read, but from top to bottom, you have first the 8 bits for the 8 data pins, and then followed by 8 pins for the address lines. So the Z80 is an 8-bit machine. So you have 8 bits for putting an address on the expansion port, and then you have 8 bits for reading and writing then data. The lower pins are control pins, basically, that give you some, you know, when actually is it okay to read and write from the expansion port. So first job is you have to understand how this magic works. Well, I quickly found out that the relevant pins that I was interested in terms of building something that connects to the expansion port, well, first, of course, the data address lines, 7 or 8 each. Then there are 2 lines for reading and writing. So the Z80, depending if you do an input or output, will then assert a signal on either the read or the write pin. And then there is another pin that says I/O request to distinguish from RAM access versus expansion port access. So basically, if the Z80 wants to write data, it would assert the I/O request, pin number 49, and it would assert the write pin number 35. So if you see signals on those 2 pins, you know, okay, the software on the TRS-80 just is trying to write out some data, and then you can look at the address it's writing to it, and also the data pins. The next thing that is kind of important is the whole timing thing. And that's also a picture taken from the service manual, and it's fairly easy to read. So it's a time diagram, so time goes from left to right. On the top you can see the CPU clock. It's kind of like a slave boat, like, you know, the drums in this 1.7 megahertz beat. And then on the lower side you can see like the timing on how the signals show up on this expansion port. So you see that a little bit below the CPU clock, you see the 8-bit address lines. So that is basically then where the CPU will then put the 8-bit address that you're trying to read or write from. Then you have this I/O request I mentioned earlier, and then the write pin. You can see like in the second cycle, they both then go low to indicate, okay, now we want to do a write cycle. And you can also see on the bottom are the 8-bit pins. They have like this kind of notation where they have like the lines going both high and low to just indicate some data is on the bus. You know, because you have 8 bits, each bit can be either 0 or 1, so it's kind of like a wild card. But you can see that then in this middle cycle, that is when you can then safely read the data from the bus, and then a little time later, then the CPU says, okay, now your time is up. You should have read the data by now, and I'm moving on. So basically that's a very simple way of how this expansion port works. So my first job was, okay, let me understand it a little bit better. Let me build some TTL logic. So very simple transistor to transistor logic to just connect something to the expansion port to make sure I understand this picture here directly, and also with all the pins. So I came up with this device here, and that was kind of my very early prototype. And if you've never seen TTL logic, it's you know, you have like these diagrams that show you Boolean logic. So basically on the bottom left you see like this little half box there with from A0 to A7. So those are the 8-bit address lines. Now don't ask me why, but I've chosen port 31 as the port that I wanted to use. And 31, you can see I put it down in binary on the bottom of the slide. So basically 31 are 3 zeros and then 5 ones. So then the way to read this diagram on the bottom left here is that you have this, this one component. Do you have a laser pointer here? Yeah, so this here is a so-called Nand Gate. Nand not because there's like a negation here, but basically this thing here asserts 1 if all of these input lines are 1. Well, actually it's flipped around because it's a Nand Gate, but the idea is that all the input lines have to be 1 in order to then for the Nand Gate to fire. Now, since I have the upper 3 bits to 0, I have to negate them. So that is why you have like these little guys over here, which is basically just a 1-bit inverter. So if you feed a 0 in here, out comes a 1. So what happens is here that if on these 8-bit lines here, you put number 31, and what would end up happening is that on this output line, you have 0. Otherwise, you have 1. So again, the logic is inverted. You know, that's kind of a bit weird, but you know, the 0 in this case indicates that we have detected what we wanted to find. And here is an OR gate, so just basic logic OR. So this will fire if either one of these guys is 1. But since they're also negated here, indicated by the star in the service manual, so the idea is that you get a 1 out here, or a 0 out here, that when both the write and the I/O request is set to 0. So long story short, you go to the pipeline down here, and where the laser pointer is right here, so whenever I'm writing to port 31, that is when you have an impulse here, a little pulse on this line over here. This thing is called a simple flip-flop, which is basically a 1-bit storage device, nothing more. But it will then store whatever I have on the D0 line here, on the data 0 line. And that will then be permanently be put on the output. So initially I then had here the an LED like this to indicate that I was successfully reading or reading the proper information from the store, from the data bus. So with that little diagram here, actually, you can already connect something else. You could already connect something else, not an LED, but you could maybe connect a relay to turn something off and on. So it just takes like a handful of TTL chips, and you could already build like a little, light switch, let's say, that you can turn your light switch off and on. It doesn't even involve a microcontroller here. Well, the next thing that you do once you have the schematics, then you use a very common technique in electronics called breadboarding. So I'll also have that at the exhibit later. So it's basically a little prototyping device. And you can see that you can also buy these connectors. So that is where I plugged in the 50-pin connector. So to also make the 50 pins of the expansion port accessible to the breadboard here. And then you have these cables that you can just pull out, and then you can basically wire up exactly to your schematics here. And you can just build up whatever you want to build, and then you can test it. Well, then, so here is then what my setup looked like. So I had my little laptop here that I'm using right now. Here's my TRS-80. Taken over the dining room table here. It's a different story. And then next comes the software side. Okay, so what I've talked about so far is hardware. Now comes software, something that actually is what I'm better at usually. Now, on the command line, if you boot up the TRS-80 and you interactively type in these out commands, you can see what I was trying to do here is out on my port 31, first a 0, then a 1, 0, and then a 1. So the idea was to turn this LED off and on. That didn't work. No, why not? That took me a long time to find out. The expansion port itself can be enabled and disabled. And by default, the ROM BIOS, or the ROM of the TRS-80 disables the expansion port. So I could type in whatever I wanted. It never came to the outside world. So I later found out, okay, there's actually a port 236, and I use the expansion port itself to turn itself on. Okay, so you have to write 56 to port number 236 to turn the expansion port on. I said, okay, great, I found that one out, so let me try it again. So second attempt, I first activate the expansion port, and then I do my little thing here again. Still didn't work. Well, spend another weekend on digging deep into the disassembled ROM BIOS listing, and I find out what the basic interpreter does. Whenever it goes back into the interactive interpreting mode, it by default again disables it. So what I was doing here, I enabled it, but because I stayed in the command line, it immediately disabled it again. I said, oh, wonderful. So then here, third attempt. So you write it as a basic program. Okay, so you just do the whole thing except to do it in basic, but then in order to slow it down, I threw in like this input X here to make it stop. So line 10, I turn on the expansion port, and I write down a 0. I hold it, so I have to hit the enter key, and then write 1, enter key, go to 20, repeat the whole thing. But then that finally, then, I don't know if I can, it is supposed to be a video. Oops. Let me go out. I think it works when I exit the presentation. And 1 second. So, okay, so here I can play the video, and it's super small, and you almost cannot see it, but you can see here my finger coming in the lower left, hitting the enter key. And in the background, like here, you can see the LED go off and on. Okay, so that we're talking about like 1 month of work. Okay, so not full time to my defense. You know? So that was already like super cool for me. At least I knew that I had understood the whole timing parts and electronics part. Now, of course, I wasn't interested in turning the LED on and off, but I wanted to then connect a microcontroller to it. Not just 1 bit, but I want to have access to the full 8 bits. So then, let me switch to my presentation. So then the next step that I did is I just took an off-the-shelf Arduino board. So something you can buy from Amazon. There are these Arduino starter kits. And again, if you have young children in your lives, or maybe by now grandchildren, you can, it's definitely something I would encourage you to get them, because it's a very nice way in a playful way to learn this technology here. But the nice thing about the Arduino is that they also have these breakout pins on the top here, so you can also then connect these cables and then connect the cable then to the breakout board. So what you see on this slide here is basically then this breadboard, and then you see a little bit to the right the Arduino next to it, and I was basically then wiring up the various I/O pins then with this Arduino, and then I wrote some code to see if I then can programmatically then also interact with the I/O port. And it again took a little bit of time, but that actually worked a little bit faster. And I was able then to read and write 8 bits, 1 byte to the expansion port, driven by a program that was running on the Arduino. Now, the data I was serving was just like an echo. So whatever I sent from the TRS-80, I was just echoing back on the next read cycle. So just as a proof of concept. So it didn't have any purpose except for seeing that I was on the right path, that I was able to programmatically interact with the expansion port. Now, this particular Arduino doesn't have a Wi-Fi module, and also this Arduino is meant for prototyping. So it has like these nice breakout pins here on the right, but it's not meant for production. So I looked around on what I should use, and I came across this wonderful little microcontroller called, it's the ESP32 family, and specifically what I used was the ESP W-Room 32 chip. And I don't have it here. I have I have a copy like a standalone on the exhibit. This little puppy costs $11. It's a dual core 240 megahertz CPU Transilla chip. It has 4 megabytes of flash memory. It has almost half a meg of SRAM. So there are also smaller versions. There is an 8266, has a little bit less, only 96 K of RAM. It has Wi-Fi and Bluetooth, and Wi-Fi both in access point and client mode. So you can also run your own hotspot of this little guy. It has 16 general purpose GPIO pins that you can program however you wish. And I knew, okay, that is what I want to use. And the nice thing is also that you can see that it has these pins on the bottom, so you can both easily connect it to this breadboard. And likewise, you can then also then use it then for whatever you want to build up next. So if you remember the card on the top right here, that's this ESP32 microcontroller. So then here on the next slide, I show you then so basically I pulled a lot of wires, and of course now you have to pull 8 bits data, 8 bits address. That's why there's so many cables on this breadboard, but the wiring is surprisingly simple. And there are a few things that you have to pay attention to. You need some tri-state buffers there to just only send and read data when you're supposed to. But actually the logic behind it is not that complicated. You can see in this prototype here, like on the bottom, you can see the push button, and it's hard to see the LED. So basically exactly what I have here on this final product is then what you can see on this breadboard. So once I got that working, then the next step was to transcribe that design over to a program called Fritzing. So there's an open source piece of software where you can basically then redo everything that you did on this prototype board, but you can just use your mouse to draw lines. And you can see that basically, I mean, it's a little bit conceptually have like these straight lines, but on the top here is the data pointer. So here's then the LED, here's the push button, here's some TTL chips, and here's the microcontroller. Down here, they flatten it out, but here's like the 50-pin connector. Half the pins are just ground, and the other half pins, here are the 8-bit data bits. Here are the 8-bit address lines that go into different chips here. But basically I transcribed very carefully then connection by connection on how I wired up my prototype. Then once you do that, and you do that very, very carefully, you don't make no mistakes. You know, of course, if you flip like one little pin here, like if you go wrong off by one, then you made a mistake. But once you do that, then the software, what it can do a layout. So basically, it can for you create the blueprint of a PCB, a printed control board. And that is the design of this PCB here. And it is a 2-layer PCB, which means it has wires running on the bottom and the top. And you can see this here in this diagram. You can see orange and yellow. So the orange ones are the top connections, and the yellow ones are the bottom connections. And you can see this routing program is pretty smart. So for example, if you look where my laser pointer hovers here, there's like this green dot here. You can see there's an endpoint of a yellow line, and then it continues with an orange line. That's basically where they punch through the PCB, and then they basically put the line from the top down to the bottom and continue in order to avoid then crosses of wires. So this routing is done automatically by the software. So then once you have that here, so the only thing you really have to do is you have to manually place where you want to have the components to go. So you have to be a little bit smart about it. So of course, like for example, like this chip over here, I know needs to have all the 8 pins of the data bus. And I know this chip here needs to have all the 8 pins of the address bus, of the address line. So of course you position them on the PCB that they are kind of close to where the connections are. That's why you can see that all these lines are almost like parallel, going immediately from the expansion port here directly to the chip. Now once you have this here, you can just package it, zip it up, those files, you send it to a shop, and there are like in the Bay Area multiple places where you can just send the zip file, and a week later you get like a box, like several of these PCBs. And then you have to get out your soldering iron and then solder everything up, and then comes the first time you power it on. Take a deep breath before you do that, and then you can only hope for the best, but in my case I was lucky. Let me talk a bit about the software side. So that is just all the hardware side. So the software side, I mean, already had a diagram that was similar earlier here. So here's the TRS-80, here's then my RetroStoreCard having the Wi-Fi module, and at the back end here, that is the RetroStore that is hosted somewhere in the cloud. It has just an open REST API. Now, the proxy here essentially scans the I/O bus on the left side, and it then does HTTP request on the outgoing side via the Wi-Fi connection. Now in my case, I had a little bit of a problem because I didn't have a floppy disk on my machine. So how do I do the bootstrapping? How do I get this RetroStore client onto the machine? So what I decided to do is, well, first of all, how did I implement the client I showed you earlier in the emulator? Well, I wrote it in C. I didn't want to go down that path again on writing Z80 code, so I wrote that in C. There's a compiler called SDCC, Small Devices C compiler, that can also target the Z80, and that's basically how I wrote this interface you saw earlier. Now, that CMD, this command file for the TRS-80 that came out of it, I packaged as a C array. Okay, so there's a program called XXD that takes a binary blob and it spits out C code as like a Java, a C array that has just all the hex codes of your binary block. And that you can include in your makefile, and then that's how you can include it in the firmware that you flash onto this microcontroller here. So then I had to type in a little tiny basic program, and I'll show you that basic program later, for bootstrapping. So basically you tell the RetroStoreCard, send down the native client. And you have a for loop that just reads byte by byte, that is again this packaged native Z80 code, and then you can run it on your computer. As you can already tell, like what I indicated with 1 and 2, there's a protocol that goes back and forth here. So the protocol between whatever runs on the TRS-80 and whatever runs on the firmware of the microcontroller. And this protocol goes via the expansion port, and it's using port 31, again, the port that I've designated as the RetroStoreCard port. And on this slide here, I'll show you the protocol. So essentially, here is what in this column, what you send to the RetroStoreCard, and here's what you get in response. So if you send 0, you will get 101 bytes in return of bootstrap code that downloads native client. If you send 1 and then followed by a 2-byte integer, you want to download a specific CMD file. So which means right now with this 2 bytes, we're also limited to 65,500 something applications in the RetroStore. And so, I don't know, we're getting close here. We're almost running out of but you can see there, so there are like, you can, like for example, if you send 2 by this identifier, you get the title of the app. If you send 3 and the ID, then you can get back the app details, so that big text blob. So each is being sent back as a 0 terminated string. You can send 4 and you get back the Wi-Fi status. So there are like there's 1 byte that tells you if it's connected or if it's in access point mode and so forth. You can also configure the Wi-Fi. So once you have it connected, you could actually then use the client to set SSID and password from the TRS-80 on this microcontroller here. So then there are some other things here, send the version and send the SSID and the IP address, so that you can also show some metadata. Well, let me show you the bootstrap code that then you have to type in. So first of all, you know, like a little, you have to do it as a basic program, so not like from the command line, again, because the interpreter automatically disables the expansion port. So here you enable the expansion port. Here you send the 0 with the out command to instruct the RetroStoreCard to send down these 101 byte bootstrap. And here's then the for loop. Also had to remember that the for loop, the 0 to 100, 100 is inclusive. Not like a Java or C++ loop where it's exclusive, the upper limit, but actually this loop iterates 101 times from 0 to 100. And then 17152 is hexadecimal 4300, which I know is some little space of RAM that is available, so that's where I download the bootstrap code. Then I read in from the port, and then then I run this, so it downloads these 101 bytes, you call the system command, and then you just jump into this same address, and that will then kickstart this download. Now, this basic program is not quite correct. Can anyone see?
INT.
Very smart, yes. Very good. So, you know, again, I've forgotten all these details, right? I mean, out is how you write 8 bits to the expansion port. And then I instinctively thought, well, reading must be in. Now, that's not true. The actual true command is imp. So here's the corrected version. Okay, that is actually reading from the expansion port. But what happens in this wrong version? Well, it also happens to be the syntax for basic arrays. So the basic interpreter says, okay, in is a name of an array. I haven't seen that, that's all right. Let me initialize that for you for all zeros. And then I'm accessing here index 31. So I was reading 101 zeros and poking it into RAM, which of course did not work, you know, but you know, initially I thought, what am I doing wrong here? And you know, I was using a logic analyzer to scan the I/O bus, only to find out that actually I was sending the data down, but it just never came there. So then, a little bit more digging, I found out this little mistake with the in and in. Anyways, so then after 2 months of pet project, Cosmic Fighter was the first game I managed to run on my own TRS-80 that did not have a floppy disk, did not have a cassette tape, does not have the fret cards, but it downloaded it from the RetroStore over the internet. So that was kind of my personal highlight. Last slide. Well, you know, needless to say that there are some more details that also took me a little time to find out, but you know, I would encourage you, if you have an idea, just to play with it. And I made some horrible mistakes. Maybe just to mention one little thing here. This 50-pin connector, there are 25 pins in 2 rows. Now, you read in the technical manual that every even pin, so 2, 4, 6, 8 is ground. Okay, great. And the other 25 pins are actually the ones that you want to, like the data pins, access pins, and so forth. The thing is, how do you number these pins? Do you go 1, 2, 3, 4, 5, 6, or do you go 1, 2, 3, 4, 5, and then bottom row? And I saw a web page that gave me wrong information. So another lesson, do not believe everything you find on the internet. So basically, my first wiring, horrible, I actually thought that the numbering is literally like 1, 2, 3, 4, like first going the upper row and then going on the lower row, which is not. And when I then saw the correct information, I thought, oh shit. And I thought, maybe did I just fry my TRS-80? But I rewired it, and it just worked. And these old machines, they are so, what's the word?
Robust.
Robust, yeah. And I'm looking for a nicer word, like resilient, yeah, but also forgiving in a way, right? I mean, they let you just do horrible things to them, but they still swallow it and they still run, you know. So anyways, you know, so don't be afraid on just playing with your TRS-80. And also just want to mention, so here on this link on the bottom here, so everything that we have done, both Sascha and I, is completely open on GitHub. So here's the link to the RetroStoreCards. Already mentioned the Android emulator is also open source. The RetroStore backend that Sascha implemented is open source. So everything from the schematics to the PCB files to the source code running on the microcontroller, plus also the native client, is all open source, also all in this GitHub repository. So some people have asked what are you going to do with it. Well, me personally, probably nothing. I have no commercial interest. I'm an academic, you know, I never figured out the money-making business. So I wanted to talk later to Ian Maverick. If I know that he builds the Fed cards and sells them, so if he's interested, I'd be perfectly happy to hand it over to him. So let me talk to him if he's interested in doing that. So, well, I guess that's it. Actually, sorry. There was one more thing, right? There's one more thing that I've forgotten here, and it's kind of like. Let me go back to my Android tablet here. Let me see if I can reconnect it. Unfortunately, I closed the. Okay. Okay, so I'm back in my Android emulator here. It runs on my Nexus 7. Remember, I have like this little shopping cart here that goes to the RetroStore. Now, the RetroStore client I showed you earlier on my emulator here on my laptop is a command file that is itself hosted in the RetroStore. It's kind of like the movie Inception, if you have seen that. It's kind of like a dream inside a dream, right? So I can actually now browse down here. And lo and behold, here's the RetroStore client. And what I can do now is I can install it in my emulation running on my Android device here. So I go back. I have a second card. Now I can click on this one here. And what you see now here is exactly what you then see on the real hardware. So I can basically browse the Retro Store by using the keyboard here, and then so it's a dream inside a dream. And here again, I can select Pete's application, get the metadata, and then here it is. Okay, that's the end. Yes?
So, all right, that is awesome, but it's also completely crazy.
What? Yes, of course.
Yeah, I mean, no. It could be that you just love designing hardware, but why is it that you decided to design a piece of hardware to do this instead of relying on some other serial solution? Like, I'm really interested why this wound up as a card and not just another piece of software.
Well, you have to have some physical connection, and using the serial interface definitely would have been another alternative. Absolutely correct. Why I've chosen the expansion port, I can't really tell you. Just a whim, I mean, I think it's faster than the serial port, especially since you download all the CMDs. So I'm guessing, I don't know what the speed was of the serial interface, but the expansion port is definitely a lot faster. Now, in terms of ease of connection, yeah, I probably could have gotten away. I mean, I still would have had the microcontroller, but I could have just used maybe one GPIO pin to then just connect to the serial port, and I wouldn't need to have all the 3 TTL chips. But the overhead for going the expansion port is not really that much higher than doing serial. So I thought it was actually a nicer solution. Now, one thing also Pete pointed out, what I really have here is not just a RetroStoreCard, but actually it is a generic access to the internet. Right? And this puppy, actually I also did mention, it can do OTAs. So the first time you boot this up, I can actually push firmware updates. If this ever becomes a product, I can push a firmware update without having to do anything. So we could put in more modules. This protocol I showed earlier, we could add more protocols, for example, for TRISBox or TRISWiki and other things that people have come up with. So I think it's more forward-looking, probably gives you more options. Yeah, it's just out of the wind.
I was thinking that that would do everything I want, except it doesn't let me hook to the internet to, browse or whatever. So putting a browser on there, or a simple browser,
yeah,
letting me put in a URL I want to go to.
Well, so just to be clear, let me maybe go back to the slide. If whatever you have in mind on doing, you just have to be aware that. One second. If I go back to this slide here. So whatever you do, you also need a component running on the TRS-80 that uses this custom protocol. Right. So it is not as simple as typing something in here. I mean, there has to be some client supporting whatever application you want to do on the TRS-80. But what I'm saying is, this microcontroller here still has enough room for additional code, so you can add more proxies for other products.
So how much flash did you say the controller has?
It has 4 megabytes. Right now it's partitioned into thirds. It has one partition for the factory image, and then 2 AB partitions for the OTAs.
Okay.
But you can also, if you want to have a little bit more, if you can repartition it to 2 times 2, and then just have an AB partition.
It's just that it occurs to me the entire retro store might fit. So you might be able to pre-download and then you have offline, right?
Sascha also mentioned that, yes, and right now we would have enough space to indeed do that. But of course, at some point, we're going to have so much content in the retro store. It becomes a cache. Well, I mean, right now it has Wi-Fi, so why not just simply download it? And the thing is also for curating, right? If I update the description, and if I'm going to add your game then this afternoon, tonight, when I have time, then I have nothing. I have not to change one thing on this guy here. I just upload something to the back end, and it will immediately show up in the emulator and also on the real machine.
Yeah.
Yes?
And so I assume the firmware that you wrote for the espresso is also included in that.
Absolutely, yes.
Yeah. So there's lots of room there to make one of those. Sorry, I'm just sort of brainstorming live in the middle of your talk.
Yes.
But thinking that one of those protocol commands could simply be to put it in some sort of pass-through mode, where it just starts basically becoming mode across the internet.
Yes, sure. Yes. Yeah. Or if the one is your friend, you can define whatever protocol you want from them. Yeah. Yes.
How did you deal with the clock speed difference between the TRS-80 expansion bus and your
Okay, so I can tell you the microcontroller that is used for the Fred is an older model, and the guy who designed it, Fred Verkoven, he had to do some, had to write portions in assembly, and also he had to include wait states to slow down the Z80. With this guy, 240 megahertz clock, it's all written in C, there's no assembly for the microcontroller. Runs fast enough to serve it on 1.7 megahertz, no problems. So even in a tight loop on the Z80 that just does a very tight in, like reading really at top speed as with little assembly that you need to make that happen, the microcontroller can easily serve data going back. Yes?
Any thoughts about making this software work with like the MIs in 3SE?
I don't know what that is.
The MIs?
MIs? No, I don't know.
Model 1 system expansion. Peter Bartlett's.
Okay, yeah.
Networking capability.
Probably might be possible, but yeah, I have only the Model 3 in my house right now, so probably I would also need to gear up on the hardware side. I should maybe mention one thing. So this 50-port ribbon cable here is a bus. So you can connect multiple devices to it. So you can physically connect the Fred card and this card over here. However, the Fred card is not a good citizen on the expansion port. It takes complete ownership. So I designed my card to be a good citizen. So I think both Ian and Fred know about that, and they hopefully will rectify that. But at some point, you should be able to also then connect both the Fred and this guy over here on the same bus. But right now you can't. There's also a warning. Yes.
You didn't have any trouble with the voltage logic levels?
Yes, of course I had. So just to mention this one thing here, so Arduinos usually, like also the one that I used during the first stage is 5 volts, which is the same voltage levels as a TRS-80, typical TTL logic. The ESP here runs on 3.3 volts. And you have to be very careful on doing level shifting, but it is not really like rocket science. So there's like one little chip here that is dedicated to doing this level shifting, to translate between the 5 volts and the 3.3 volts. You just have to know what to plug in and be sure that you don't just simply wire it up, because then you fry this little guy here, because if you put 5 volts on a GPIO pin, then game over. So yes, you have to be careful, but there's solutions for that. Other questions? No? So we do have an exhibit here right when you come into the floor, the side room, and talk to us and tell us what ideas you have. Thanks again for coming.